machines involve cutting and drilling holes, lots and lots of holes. So holes, mainly holes for nuts and bolts. So there are lots of bolt holes all over the machine that you can see. Bigger hole there. Then there are bigger holes for bearings and irregular holes like the cutout in the inside of the bike wheel. And then for all the panels, all these things are bolted on. There are literally hundreds of holes in every single machine. Well, of course, for a lot of things now, the parts come designed by CNC and they're laser cut, so they come with all the holes drilled. But for one-off machines, or for prototypes, or for maintenance, it's still essential to drill holes. At first, I just kind of assumed drilling holes was trivial. You just have a drill bit and a drill, and that's it. But the more I thought about it, that there is rather more to it. So that's the reason for this video. As always, here's the chapter list so you can quickly find any section. Also, as always, I should remind you the video's really just about my own experience of drilling holes. I'm not an expert. It wasn't easy making holes in the Stone Age. Can't easily make a bit of stone into a drill bit. They used pointy things, sometimes just thorns and sometimes bits of bone or antler. And of course they made needles out of that to cut through leather and cloth. I cut a bit off this antler and made it into a pointy bit. So I'm now going to try and cut a hole in a bit of wood with this bow drill. Push the pointy bit of bone into the end there. So you can see it's slowly making a bit of sawdust, but progress is very, very slow. Oh, it's actually a bit better than I was expecting. But they were amazing. They managed to drill through really hard things like granite. What they did was that they made a sort of slurry of sand and grit with water. That's better. And you put this into the hole. And now we'll try again. Let's see how that's going. You can't really see what's going on because of all the sand and slurry. I'll just go and clean that with the air gun. Well, there it is. It's about 1/4 of an inch deep. I don't think I'd have done very well in the Stone Age myself. But I am familiar with this idea of adding sand and grit. It's a bit of a menace with bearings. Quite often I've found taking a bronze bushed bearing to bits that the hard steel shaft has worn more than the actual bush. And this is because dirt gets into the bush and then there are these hard particles of dirt embedded in it, eating away at the hard shaft. So certainly there's evidence that Stone Age people did drill holes in granite. Quite astonishing really. But of course by the Bronze Age, with metals, they were much more suitable for making drill bits, and even more so with the later Iron Age. I had a go at making a sort of Iron Age drill bit, just flattening a bit of 6mm steel and grinding the edges, and I'm quite amazed how well that worked actually. Off I go. almost as good as a real one. So it really wasn't until the Industrial Revolution that the complicated machine tools could make much more complicated drill bits. And then their design started to change quite radically. So this lovely great thing is a drill for drilling the cross ties on railway sleepers. And you can see the actual bit is really quite complicated. For a start, it's got this spiral, sort of not that different from a modern twist drill, which is sort of Archimedes' screw to channel the wood shavings up to the top of the hole. Then it's also got this screw thread on the bottom, and the idea of that is to pull the drill bit into the hole to keep it cutting, which actually works surprisingly effectively. Well, although this is an unusual example, all the drill bits of the time evolved a bit like that. I borrowed some old ones from a friend of mine. I suppose there are two separate sorts. There's some that just have a single flute and some that have multiple flutes. But the design of these things didn't really change until the advent of battery drills, because at the time practically all holes in wood were drilled by hand. And there are a great variety of hand drills. They evolved from the bow drill via some sort of entertaining intermediate stages. But the one that really stuck was the brace, a surprisingly effective tool, which I will try to demonstrate. Well, I almost went through that bit of 2x2. Yeah, it works quite well. For smaller holes, you needed something that whizzed round faster, and so then there was these hand drills. I actually had one of these in my 20s. It's a horrible thing. I never could do much with it. There was an old boy I knew who could make it do anything, so I guess it was just what you get used to. These have all been superseded today. The modern descendant really is these Forstner bits, and I still use them myself if I want a neat hole, particularly in a bit of plywood. A beautiful hole. But generally drilling holes in wood is easy, particularly compared to drilling holes in metal. Drilling holes in metal requires much greater pressure, so you have to push incredibly hard. The drill needs to go around faster, so it's not very practical with hand drills. It wasn't really until the Industrial Revolution and steam power that it was possible to drill big holes through steel. So the design of the drill bits I've shown you so far for wood diverged from the design of drill bits for metal. So drill bits for drilling holes in metal are rather different. Well, for a start, this is the sort of classic shape. For a start, you can't have the fiddly screw threads or anything on the end. They'd very quickly get blunt. In fact, all the cutting edges are much sort of steeper angle. So on a drill bit for wood, you can have the cutting edges can have angles of 20 or 30 degrees. It's sort of similar to a wood chisel. Whereas for these metal cutting drill bits, the cutting edge is along here. That's the angle between the face of the drill and the flute. It's more like 60 degrees. Then actually there are also many subtle differences in the optimum angles for cutting every different type of metal. Yeah, the other thing about drills for metal is that they have to be more solid. So there's less space for the shavings to go up, the swarf to come up, but they need to be more rigid than a drill for cutting wood. But this design is so versatile, it'll cut almost any material really. So if you go to a shop and ask for a set of cheap drill bits, it'll be this basic shape. It was invented by an American inventor called Stephen Morse in 1864. He also gave his name to the Morse taper. This is this tapered bit on the end of many drill bits, which is also still very widely used. The drill press, things fit in there with Morse taper, and also the tailstock of my lathe. And it is rather magical really. You just put the drill bit in the end and it sort of stays up by magic. I usually sort of tap it a bit, but it's just because the taper is so narrow that it just sort of wedges into the equivalent cone shape, if you like, inside the drill press, and that'll hold very, very rigidly. If the angle was greater, if it was more splayed, the drill bit would just fall out. But if it was steeper, more nearly parallel, then it would just get completely jammed in the drill press and would be impossible to take out. Morse's angle of about 1.5 degrees just hit the perfect sweet spot. Removing a Morse taper is equally simple. There's a slot in the column of the drill press, and what you're looking at in the middle is the top of the drill bit. So we just have to put in a wedge-shaped bit of metal and give it a tap with a hammer, and the drill bit's released. Of course, small drill bits just have the parallel shanks, and you need a chuck, but the chuck, just the same as the big drill bits, fits in the lathe with this Morse taper. And so exactly the same, I can just tap it in place and it'll just stay there. A wonderful, simple invention. Often, the most difficult thing about drilling metal, particularly steel, is applying enough pressure, pushing the drill bit in hard enough. It's a particular problem for me when I'm working on site in the arcades. So I always end up with situations where I have to drill holes in steel with my battery drill, and it's not easy. So if you do have to, obviously the best thing is to be drilling downwards, and then you can put all your weight on the drill. If you can't do that, another quite good way to do it is to have something to tension your other arm against, so you can then get much more pressure on the drill. That helps in some situations. The worst one is when you're drilling something above your head and you really can't have anything to get any pressure against. And then I find the answer is just to always use a brand new drill bit and start with a pilot hole too. So I'll see how I get on with that. I'll try this one out. Okay, so I'm going to drill one up here. And I can still get a little bit of pressure by pulling backwards with my other arm. But a new drill bit makes a big difference. The other difficult situation that I get into is when I'm trying to drill a hole in a place where I can't get the drill behind it. So if I want to drill in the far side of this bit of box section, there's no space to get the drill in there. So then I use this angle attachment and a very short drill with a hex shank. So if I put that in there, this is about the shortest I've found. So that's about 3 inches, I guess, 75 mil. Put this in the drill. So now that goes round. So now I can get the the drill into this awkward position.
You are a failure. Score by eating as much as possible. Now, push the button.
Very satisfying. Restart it now. The easiest way though to drill holes through metal is with a pillar drill. Makes it easy to apply a lot of force, and also you get a hole that's accurately at right angles to the table. They're brilliant tools, and you can get small ones very cheaply. Over the years though, I've modified mine in a few ways, which I thought was perhaps worth talking about briefly. The first thing is, most pillar drills come with this feature of a table that will tilt one way or another. But I found that when I was putting heavy things onto the table, that it would often get out of true a bit. In the end I got so fed up with it, I've actually welded it solid down the back there. I'd never ever used the tilting feature, I always find other ways around it. So that was a big improvement. The next thing I did was, it originally came with a conventional keyed chuck, and I swapped that for this Albrecht keyless chuck, which you just do with your hand, just like a battery drill chuck. But these are much better made, and they grip much harder and last much longer too. So that was an improvement. Then the method of changing speed on these basic drill presses, they're belt drive, so you have to in the top here you have to slacken off the tension of the belts and swap them around and retension them, so all that takes quite a while. It's infuriating if you have to do it for every single hole, so a variable speed drive's a lot better. So at the time I had a great big old DC motor knocking about from a treadmill, and a Variac variable transformer. Go down to almost nothing. And I even added a reverse too, so it will go backwards, useful for threading holes. And I should have said I wired it up to a foot switch, because then you've got another hand free to hold the work and the vise. I find that useful. Well, although drill presses aren't particularly scary machines, you do have to be careful how you hold the work. Traditionally you have a vise, the machine vise it's called, which clamps the work in place, and then the vise itself can be clamped to the table, so everything is very rigid and secure. And this is important because the drill bit can catch the metal, particularly as it breaks through on the far side, which I'll try to demonstrate. So where shall I do it? Let's do it there. So not holding it with a vise this time. So you don't want your hands to be anywhere near. But I have found that with time you get more confidence, and belt drive is a good thing because it limits the torque. So it can't pull round too hard, the belts just slip and the drills stop. So for smaller drill bits, I have increasingly found that just holding bits of work with a pair of mole grips is very useful, because it's very quick just to pick them up and find the right place and drill straight away. But it's not the thing for beginners. You do need to get a feel of your drill press and get familiar with it, what sort of forces are involved before trying it. So getting a hole in the right place sounds quite trivial. The time-honoured way to do that is with a centre punch. All I have to do is to put the punch in the right place and well, that wasn't too bad, but quite often, even while I try to do it carefully, it's slightly to one side. And I only recently learnt this trick or discovered this trick, that if it is to one side, you can just punch it a few more times, pushing the centre point of the punch mark in the right direction. The other one that I like is this little thing called the atomic dot punch. It's an old tool from the 1960s, though they're still made. And the idea of this, it's got a spring inside. So you just push it down on the metal and at some point it'll release the spring, so you don't need the hammer. It's not a particularly big punch, but you can do it a few more times, enlarge it, or sometimes you can then put an ordinary punch on top. So that helps a bit. In other situations I find these things useful. These are called transfer punches. So if you're trying to mount a motor or something on a bit of steel underneath, but you can't get a punch in, it's too deep, they're just a bit of shaft with a point right on the end. So you drop this through the bit of equipment that you're mounting, tap it on the top, and you've got the hole in the right place underneath. I think the final thing that I find useful for getting holes accurately in the same place are these bits called centre bits. The thing is, they're so short that they're very, very rigid, and I use them particularly in the lathe. That's what they're really built for. Sharpening drill bits isn't easy. I've tried various methods, and I think over the years I've found really that I get on best by just using my linisher, doing it by hand. So I'll start with sort of sizing up and getting a feel of exactly where I need to hold my hand and the angle I need to be at. And then I'll do a sort of rotating motion like that. It's a bit noisy when I get the linisher going. Well, doesn't look too bad, but there are different things to take into consideration. You have to have this angle has to be about right. I think that's a little bit too pointy, but not too bad. Then the side faces, these have to back off a bit from the cutting edge. That doesn't look too bad. And then the other thing is that it has to be even, so that the centre is in the middle of the drill. So this would probably cut better than it did before I sharpened it, but it might wobble about and not cut completely centre, or still cut a slightly oversized hole. So a few years ago I did try buying a gadget, a drill doctor. It's quite fiddly to use. So first of all, you put your drill in its sort of chuck, which goes in one hole, and you have to get this this accurately lined. That's it, that's located. Then you tighten up the chuck so that it's accurately orientated. So now you can put it in the next hole with the grinding wheel inside running. Well, I don't know. I think that's pretty odd, really. Kind of multifaceted. I wouldn't say that's any better than what I could do on the linisher. So these drill doctors, I've never had much luck with them. More recently, I've just taken to buying quite good quality drill bits and just replacing them when they get blunt. It makes drilling holes just so much easier, faster, more accurate, and also safer because you don't have to push so hard. It's sort of one of my luxuries, if you like. Of course, metals have very different properties one from another, and so there are lots of different speciality drill bits for different metals, with different angles on the end and made of slightly different materials, particularly extra hard materials for harder steel. So I don't particularly like the really hard cobalt drills myself. I find that they break rather easily. I generally use just a sort of good quality all-rounder drill bit for steel for practically everything. But there are some metals that present particular difficulties. So aluminium, which is quite soft and shouldn't really cause any problems, but the problem with this is that the swarf tends to get trapped in the cut and also in the bit. Pretty jammed up now. And sometimes it's really hard to get the, I can't, oh, so I can just get this one off now. It wasn't happy, but there's a simple solution to that, which is just WD-40, or cheaper version paraffin works just as well. So if you put a bit of that on the drill bit, I hope you'll see that it works very differently. I'm having to use much less pressure, and I'm just going through now. It's still a bit stuck, but not nearly to the same extent. They come off much easier. Copper's another metal that can be tricky. Most of the time it's fine, but it's a soft metal and it can just grab, the drill bit can just grab the swarf and dig right into the copper and drag you round with it. I've had one or two nasty experiences. You have to go cautiously. Hard steel is another difficult one, hardened. And some hard steels are harder than the actual drill bit, so you're not going to get anywhere. But one technique I have found useful, things like this collet from my milling machine, these are case hardened, so they're only really hard on the outside. So then what you can do, you can just grind the outside off with an angle grinder, because angle grinders will go through really hard stuff. And then with the softer metal underneath, you can drill the holes. So in this case, I managed to drill and thread the two grub screws I wanted to grip the actual cutter. I've found this useful on many occasions. But probably my least favourite metal is stainless steel. Here the problem is a bit different. It's actually not much harder. 304 isn't much harder than ordinary mild steel, but it has very poor thermal conductivity. So this means that all the heat from the cut is just going to hang about and make the drill bit and the work hotter and hotter. And this also has the effect of polishing the stainless steel and making it harder. So you're in a sort of vicious circle. I've lost track of the number of drill bits I've ruined just from trying to cut holes in stainless. So I think for a starting point would be to always use a pilot hole. Drill a pilot hole. This will make it a lot better, a lot easier. thing is to always try and use a sharp drill bit. That makes things easier. A pilot hole is particularly good because there's actually a small flat section in the centre of a drill bit. It's easier to see on a great big one like that, but that really struggles to drill in that bit. But by drilling a pilot hole, you've drilled that out, so then you can just rely on the outer cutting edges to do the work. You could see the smoke from the oil. Even that was getting hot. Drill bits aren't very good at drilling through thin material, particularly thin metal. So, you know, a little bit of a shim like this, if I just drill a hole through it, it's really quite raggedy and nasty. Well, there are ways round this. The low-tech way is to make a sandwich, is to really sort of clamping the metal between two bits of wood. So now if I drill a hole, it shouldn't come out so ragged at the edges. There we are. It's still not perfect, but it is a bit better. But there is a completely different way of cutting holes in thin things, and that's to punch them. So for leather and softer materials, you get these sort of wad punches. What you really need to punch through steel, you need something a bit more beefy. And the big difference here, it's more like a hole punch, is that it's got the punch, but it's also got something that it's punching into. So it's shearing the metal on the edge, between the edges of the punch and the edges of the female die. And this will actually go up quite a bit thicker, so you can punch aluminium up to 2 mil thick. I say. And even this is a minnow compared to the enormous industrial punch presses that can punch whole sheets of perforated metal. Drilling large holes. Well, this monster is my largest sort of conventional drill bit. Came with a job lot, and I have to admit I never used it. Beyond a certain size, this drill press really isn't quite sort of rigid or heavy enough really to stop the vibration, and you get some quite odd effects. So I'm going to try and demonstrate that with drilling a 3/4 inch hole in here, and just see what happens. Well, actually that wasn't as bad as sometimes. The hole it's drilling isn't round, it's sort of multifaceted. Once the drill gets right into the metal, it would be better, but you very often get these 5-sided or 7-sided holes. So what I tend to do is to use hole saws, and I've got the whole rack of them there. these hole saws fit in a holder, and these aren't particularly accurate, I have to admit, but I never used to think they would drill through thick metal, but they'll quite happily drill through 1/4 inch 6mm steel. Now I can put some oil in the groove. And there we are. I find them very useful and somehow cope with the lack of accuracy. For a lot of jobs it's not that critical. Or sometimes, like if I can turn something in the lathe to fit accurately the size of the hole that I've ended up with. Tiny holes, the main problem is simply breaking the drill bit. I've got some very tiny drills. I think some of these are just 0.3 of a millimetre. But I can't actually remember ever managing to drill a hole without breaking one of the smallest ones. It's for good reason that ordinary drill sets, the smallest drill is 1 mil, and that's about the smallest size that's just about practical. But even this causes problems. Well, for a start, the chuck doesn't go down small enough to grip it, so I have to use a little pin chuck in the big chuck, and then I can just about okay, so I'm going to try and drill through a bit of 3mm steel. It's quite a challenge for it. I can go quite fast, go pretty fast with the drill, but I mustn't press hard or I'll just break the bit again. Some oil and off I go. Nice clean hole. So it is possible. But there's a much more sophisticated exotic technique for drilling tiny holes, which is called spark erosion. So you have a tiny metal tube, and they can be much smaller than this one. I think they go down to about 1/4 of a mil. And these are at quite high voltage with water squirting through the middle, and as they approach the metal it completes the circuit and you get the sparks, and it's the sparks that eat away at the metal, and then all this water flowing through flushes out the debris, and it can keep going deeper and deeper without the tube actually ever touching the metal at all. So in this example it's drilling a milling machine cutter, hardened steel, and that's just for demonstration. But if you turn it round, they can also drill these very deep EDM holes through drill bits to squirt coolant right on the cutting edge of a drill, and they also used for cutting exotic metals of turbine blades in jet engines to keep them cool. It's an extraordinary technique. My lathe is a lot more heavily built than my drill press, and so with that I can happily use drill bits up to 25mm in diameter.
tell it's cutting well when you get this long swarf. So it's a bit of a menace to get rid of. Some machines have a cutter that chops it up. Perhaps I should have said a bit more about the speed. There are sort of precise speed tables for the cutting speed, but I tend to do it by trial and error, and I think I used to drill a bit too fast, and then the drill gets hot and the oil gets too hot. I've used slower speeds than I used to. I think the deepest hole I've drilled on the lathe is about 200 mil. Beyond that it gets really hard. It's not usually a problem, but one thing I often do in the lathe is to make bearing housings. So if you have a bit of bar and you turn it down so that it can take a ball race in both ends, you've then got a very rigid bearing assembly that you can then bolt onto a frame. But sometimes I want the two bearings to be much further apart, sort of 300 or 400 mil. Well, the answer to that is very simple. You don't start with bar, you start with tube, a thick-walled tube. And then what you have to do is to find a bearing that's the outside diameter of the bearing is just bigger than the inside diameter of the tube, and then you can turn this to precisely to fit the bearing. And that's a solution I've used on a lot of machines. It's very quick, easy to do, and works very well. But actually with a lathe you can drill holes as large as you like. But with this tool, this is called a boring bar. Though it's not boring because it's very, very useful. So that goes in the tool post here. Clamp it up. And the other advantage of the lathe is that you can get much better lubrication. This has what's called, it's a water soluble oil that you can just pump onto the cut while it's cutting. And of course I could keep on going making the cut as large as I wanted, transforming this into thin tube if I needed to. So boring bars are very useful. But the boring bar isn't the only way to cut large precise holes. I can also do them in my milling machine. So one tool that's useful are these cutters that are really designed for magnetic drill presses. I don't have one of those myself. It's you need to be making things with really heavy steel for them to stick to. But these cutters are very precise. This is a 25mm one, which will fit in the milling machine. Then there's also an older device called a fly cutter, and this is adjustable. You can adjust how far out the cutter comes from the centre, and it looks all rather improbable. Quite often I'll start a hole with an ordinary hole cutter in the drill press and then move it across to here to get a more precise hole. It cuts a beautiful hole. The only trouble is finding the centre, and also working out the exact diameter. So I don't use it that often. It's just so fiddly to get it exactly right. But the holes are beautiful. The digital readout on a milling machine is also useful for drilling holes, or particularly for drilling precise spacings between holes. So if you drill one hole, you can set the readout to 0, and then you can drill a second hole very precise distance from the first. So say I wanted one 50mm along. Crank the mill along. But another use of the mill with drilling holes is I quite often make a bracket to fix on a machine that I need to be a bit adjustable. So I actually need slots rather than holes for the bolts to go through. So then you just have to change the bit for one of these nice end cutters. They're designed for milling machines. So I'll just take the centre bit out. A bit of oil is good for this. Once I've drilled a series of holes, I then connect them all up. So it really makes making slots very, very easy. A common problem I have with holes is getting them in the wrong place. I mean, I'll mount a part, bolt a part onto a frame, and then later realise it's in slightly the wrong place and I've got to move it. Well, if it's quite a way out, then you just drill another hole. But if it's just like in this example, it's just 3mm out, half the width of the hole, and you want it to be sort of centered there rather than on the original, then that's quite tricky, because if you drill there, the drill will wander over back into the original hole. So then you have to weld up the hole, which isn't entirely straightforward. So I'll try and demonstrate. So doing it in short pulses of weld stops it just blowing through the metal. Well, that helps, but probably on the back side it's still quite a big hollow. That wouldn't do, so you really have to weld up both sides, or otherwise what will happen is the drill will get halfway through and then it'll wander back to the original hole because there's just a gap there. So I'll now do the second side. That's a lot easier, but now I've got to grind it all back flat before I actually re-drill the hole. So there we have the steel. So then you centre punch it. And also this is another good occasion to use a pilot drill, which will definitely help the final one go through in the right place. Okay. It often makes that slightly funny noise as it's going through sort of dissimilar metals. But actually, that's a pretty good job. Even if you've moved a bracket far enough to just drill a completely new hole, I think it's often worth welding up the old one, just so that when you're maintaining the machine later on, you know which one is the one to go for. Drilling holes in concrete and brick is a bit different. For a start, you need a different sort of drill bit. It's got a tip to it. I think it's some sort of carbide tip. And then you probably know you have to set your drill onto hammer action. That's a hammer action. And then away you go. But if it's your experience anything like mine, it's quite a struggle with a battery drill. I don't do it very often. This drill's pretty rusty, but that's partly because it wasn't until about 5 years ago I finally bought myself an SDS drill. Now this has a hammer action, but it just works so much better. A clever cam mechanism hammers a weight inside the drill against the end of the drill bit. Almost effortless. It's very satisfying to use actually. So if you do have to drill holes in concrete, it's well worth buying an SDS drill. They're not that expensive. You get battery ones too. The techniques I showed in this video for drilling holes in my workshop almost seem high-tech in comparison to this rig drilling a borehole for a neighbour. They drop a steel tube down the hole with a heavy weight on top. The winch then repeatedly drops the weight onto the tube, forcing it down and filling it with soil. What you see at the top is an outer liner tube which drops as the hole deepens. Every metre or so they have to lift the tube and the weight out to empty the soil, which is sand in this case, but it's a messy business. But though low tech, the advantage of this technique is that the rig is very compact. Deeper and wider holes need much larger machines, pile drivers. I spotted this one near the arcade. Its astonishingly long drill bit seemed the perfect finale for this video. Bye!